Good morning, everyone. How y'all doing out there? I wanted to say I really appreciate y'all coming over and seeing what we're going to do next. Now, many times in your electronic repair career, you will have to power up a board outside the rack. Now, this board right here is an Aggie drive encoder input card, and right here, let me turn this around so you can see it. Its model number is IMC-09F, and these DB15 connectors are the encoder inputs. But you will have to power up this board outside the rack so you can look at certain things with your oscilloscope or your meter. Now, I'll show you how I prevent myself from being stupid. I'm going to use this power supply to supply 5 volts to this board. But you can see that there's programmable logic on this board. Here's 2 gals. I'm not sure what the part number is, but I can see that it's made by Lattice. Here's an IC right here with a label on it. And then over here, this is probably E2PROM or flash, but there's a label on that, IC right there. And you don't want to put ground on 5 volts VCC, and you don't want to put VCC on ground. You don't want to get those two crossed up, because if you do, we've just wiped out everything on this board. Logic and programmable logic is not meant to be powered up backwards. So I'll show you how I prevent myself from doing that. Let's get a couple of Sharpies. Let me go over here. And where's my Sharpies? Here they are. I have a red Sharpie for VCC and a black Sharpie for ground. And we are going to connect to this Euro connector. This is where our 5 volts and ground will come in addition to other I/O. So let's get the camera closer and I'll show you how we do this, how we determine where 5 volts and ground is on this Euro connector. Give me a minute to move the camera. Okay, from the data sheet for a Lattice GAL 22V10, pin 24 is VCC. That's where we apply plus 5 volts to that GAL. And pin 12 is ground. So we're going to take our meter, set the resistance mode, and the beep turned on so we can hear the tone. And we're going to determine which pins on this Euro connector are ground or which are 5 volts. So let's take our meter and put on pin 12, that's our ground of that GAL. Okay, it's not the leftmost pin. Okay, it's the second one over from the left. Let's see if anybody else is ground. And the last pin on the very right top row is ground. So I'm going to take our black Sharpie and I'll mark that second pin over from the left and the last pin on the right. And that'll be a visual indication to us which pins are logic ground. Now, I'm going to try and get over here to pin 24 with our meter. Pin 24 is VCC, that's where we're going to apply the 5 volts. Let's see who 5 volts is. Okay, the very leftmost pin is 5 volts. Let's see if anybody else is 5 volts. A couple of pins right there. Okay, so the firstmost pin from the left and the third are VCC, our 5 volts. So let's take our red Sharpie and we'll mark those 2 pins. And that will give us a visual indication of who is plus 5 volts and who is ground. Let's go ahead and connect our external power supply to 5 volts and ground. I'm going to use the leftmost pin for ground, for 5 volts, and the rightmost pin for ground. 5 volts, ground. I keep wanting to say ground for 5 volts. Don't be stupid, people. Don't hook them up backwards. 5 volts, ground. 5 volts, ground. Oh, okay, here we go. I'm going to turn this around so we can get that power supply closest to that Euro connector. And while we are hooking this up, I'm going to look at those 5 volt and ground pins with the meter right here. Okay. Hope you all can see that. Let's set our external power supply. Move this board out of the way just real quick. While we're adjusting that power supply. Brown clippy lead is going to be for our ground, and this purple clippy lead will be for our VCC. Connect that right there. Connect that right there. Let's lay that down there. Connect our ground to the black lead, and our positive to the red lead. Let's adjust this so that we have 5 volts on the meter. There's 5.26. Let's bring it down just a hair. 5.23 volts DC. Okay. I'll turn that off. We're going to look at the 5 volts and ground with the oscilloscope. I like to do that because if I had this hooked up backwards and we're looking at the VCC and ground and it goes negative, I shut things down real quick. That means I'm hooked up backwards. Okay, let's disconnect this right here. Get some more clip leads for the oscilloscope. Okay, I'm going to connect ground to this farthest pin over here. Get my close-up glasses on so I can see what I'm doing. Okay. Ground is on that pin right there. And VCC is going to be on this pin right here. Okay, let's go ahead and hook up the oscilloscope. We'll take this brown wire, connect over here to ground on the board. And we'll connect that to ground of the oscilloscope. Set that back over there. We'll take the oscilloscope probe, we'll take this blue wire and connect to the VCC pin of that Euro connector. Now let's double check everything. Okay, the black lead from the power supply ground is going to what we have marked in black. And the red lead from the oscilloscope is going to the pin that we have marked red. Now I'm going to set my meter to beep mode again. And we're going to go on ground. This is double checking, triple checking, because you don't want to hook these up backwards. You'll destroy your board. I'm putting the red lead of the oscilloscope, we're in continuity mode now, on ground of the GAL, and we're going to go over here and measure. Let's see if I can get on it. I got to get my close-up glasses off. There you are. Okay. Tighten these up a little bit. Okay. Are we still in beep mode? No, we're not. Okay, there's beep. Okay, I'm on ground of the GAL. And there's ground of the power supply, so that's good. Now we're going to go on the 5 volts output of the power supply. And we're going to go on VCC of the GAL. And there we have continuity. So I feel very confident that we are hooked up correctly. We're going to watch that scope. If it goes negative, we're going to shut things down real quick. Okay, here we go. All right, we went positive, but we're not fully at 5 volts. Let's go see what our actual voltage is. And the DC undervoltage LED is on the board. So, let's see. Okay, black lead on ground of the GAL, pin 12. Red lead on VCC of the GAL. This should be 5 volts, but the board has pulled it down. We're at 4.230 volts DC. Now, most TTL, not all, but most, let me go ahead and turn this off. Most require a minimum voltage of at least 4.7. Now, that's not every TTL, but most. So the minimum voltage that that TTL IC requires is 4.7 for it to come up. Let's put our meter in place of the oscilloscope, and we'll gradually increase the external power supply voltage until we have a good 5 volts. Okay, our meter's clipped in instead of the oscilloscope right there. We're in volts mode. Let's turn everybody back on. Okay, there's our 4.2, it's like 4.26 volts DC. Our DC undervoltage LED is still on. We're going to take and gradually increase that voltage until we have a good 5 volts. Oh, look at that. At 4.7, we have 02 in the display and a green LED right here. Let's go ahead and bring it all the way up to 5. Not too far now. Okay, that's 5.2 volts DC. We have 02 in the display, and the green LED is on. Now, we can look at different things on the board with our oscilloscope and our meter. Now, we've successfully brought this board up. When these boards are in the rack, you can't look at nothing because unless you have a card extender, but I don't have a card extender for this board right here. So this is the safest way that you can bring up your board without destroying it, because if I get that 5 volts in ground backwards, it's done. Because what happens is when you get these voltages backwards, the programmable devices, they'll be erased and damaged, and all of these other ICs on the board would probably be damaged also. Oh, just always have to be very careful. Get a picture of that front panel display right there. Okay, you got to see how to safely apply an external 5 volts from that power supply over here to your rack mounted card without destroying it. I hope you all enjoyed that video, and y'all have you a good day and enjoy the times with your family. Time is short. It goes by fast. Before you know it, your little babies are all grown up. They've got children of their own. And time never stops, does it? Okay. We'll see you in the next one. Have you a good life, all. I hope these videos make your life and your career in electronics repair just a little bit easier. So thank you very much. Thank you very much. Goodbye. We'll see you in the next one.